Hello everybody. Today we are going to look at the last section of notes for the Unit 1, and this is about triangle congruence. So this combines the 1.4 ideas about proofs with the 1.5 ideas about congruent triangles, and now we're going to prove that two triangles are congruent. But first we need to explain some vocab. The first one is called CPCTC. It's an acronym. It stands for corresponding parts of congruent triangles are congruent. So this means that if we have two triangles and we already know that they are congruent, we can take pieces of those triangles and say that the pieces must be congruent as well. So if we have two congruent triangles, and maybe they have congruent angles, or maybe we can say that this side and this other side of this triangle are congruent. So the parts of those triangles are also congruent. The other property today that we have is called the reflexive property. That one's really simple. It says A is congruent to A. So everything is congruent to itself. That might seem like a no-brainer, but we do need it. We need it in case we have two triangles that share a side, and we need to identify the fact that they share a side that's congruent between both of them. We'll see how that works in a minute. So here is our first proof for today. We have to put in the reasons for this proof. So we've got some given information. AD is congruent to CD. We can say that's given. B is the midpoint of AC. Well, we can say that that is given as well. Every time that we see a congruent statement in the statement side of our proof, we can mark that on our triangle diagram. So AD is congruent to CD. I can go ahead and put that as there. And then we can say, well, because B is the midpoint of AC, that means that AB is congruent to CB. We use the definition of midpoint to make that leap. So definition of midpoint. And now because I have AB congruent to CB, I can put those congruency markings. And then finally they say, well, BD is congruent to BD, which does make sense because BD is shared between both triangles. So it's congruent in the left triangle to itself in the right triangle. We're going to use the reflexive property to explain that. And although I don't really need to put a congruency marking, I'm going to show it anyway just so that those triangles are all completely marked. That way, when we prove that the triangles are congruent, we can easily see which congruence postulate we're using to show that congruence there. Okay? So, oh, you can't even see what I'm doing. There you go. So this is going to be side, side, side congruence, or SSS. And that's the congruent statement that we need for the end of our proof. Down here, we're going to prove that these two triangles are congruent. And we've got some information for that. So let's make a T-chart. And we've got our statements. And we've got our reasons. And we're going to go through here and we say we're given some information. So statement 1, EF is congruent to JH, because that's given. And angle E is congruent to angle J, because that is given. And then we need to prove these two triangles are congruent. So the two markings are already given to us. Now we have to look and see if there are any other things that we could mark here. And indeed, there is another pair of congruent angles. It's these two angles right here. Those two angles are vertical angles. So we can say angle EGF is congruent to angle HGJ. And the reason for that is just vertical angles. They are vertical angles, and we know vertical angles are congruent. So we'll use vertical angles there. And then we say, well, do we have enough information to prove that they are congruent? And we do. So we'll come down here in number 4. Triangle EFG is congruent to triangle JHG, And the reason for that, we'll look at our congruence postulates and we'll say we have an angle, and we have a side that's not included between those two angles. So this is going to be angle, angle, side congruence. Or a side, angle, angle if you prefer. All right. On the back of these notes, we are going to talk about using CP/CTC, or going further in our proofs. We're going to prove that two triangles are congruent, and then we're going to go one step further and talk about the fact that their individual pieces have to be congruent. So we're going to go here with statements and reasons. I can't spell reasons, like always. And we're going to work with circles this time. So when we take a look at this, my first statement is going to be the given information. This symbol means circle with its center at P. So my statement is I have a circle with its center at P, and my reason is that is given to me. All right, then I say, well, how am I going to go about proving these two triangles congruent? Because my conclusion, it says prove that AB is congruent to CD. But with all the proofs that we do today, we're going to prove that the triangles are congruent first, and then use CP/CTC to prove that the two pieces are congruent. So I look at this and I'm thinking, well, I do see a pair of vertical angles. They're right here. So I'm going to go ahead and put that in. So I'm going to say angle CPD is congruent to angle APB. And the reason for that will be vertical angles. And I also know something else about circles. I know that every time that you put a line that goes from the center of a circle to the edge of a circle, that line is called a radius, right? The center to the edge is a radius. The center to the edge is a radius. And I know that all the radii of my triangle must be the same length. That's kind of the point of the radii of my circle, sorry. It's kind of the point of a circle here. So I can say, I'm going to make a big, long congruency statement. I can say that PC is congruent to PD, is congruent to PB, is congruent to PA. Got all four of those side lengths that are congruent there. And the reason is the definition of a radius. A radius is always going to be the distance from the center to the edge of a circle, and so it's always going to be the same. So definition of radius. All right, so I can put those congruency markings. And now when I look at my circles and when I look at the triangles inside of it, I can see that those two triangles have enough information to prove that they are congruent. So I can say triangle CPD is congruent to, I've got to make sure my names are right, CPD BPA, so triangle BPA by side, angle, side. Side, angle, side congruence. And now that I know that those two triangles are congruent, I can say, well, because the two triangles are congruent, I can also conclude that AB is congruent to CD. So step 5, AB is congruent to CD by CPCTC. Corresponding parts of congruent triangles are congruent. One more proof for us to do together here. This is going to be a long one, so make sure you give yourself a nice long line here. So we've got our statements, and we've got our reasons. And we're going to go ahead and look through everything that we see. We are given two pieces of information. This is not one of them. This is the wrong one. It should say something else. It should say that XZ bisects angle WXY. We'll fix that for you. So our first given information is that ZX is perpendicular to WY, and the reason for that is given. We also know that XZ bisects angle WXY. The reason for that is given. So then we say, well, what do we do with those two pieces of information? How can we turn those into congruent statements in our proof? How do we make these two triangles become congruent? So one thing I see is this bisect word. And I know that if an angle is bisected, it's split into two congruent angles. So if xz bisects, that means that wxz and yxz are the same. So I'm going to put that in my proof. Angle wxz is congruent to angle yxz. And the reason for that is the definition of bisector. I know that a bisector creates two congruent angles. So definition of bisector. Now it's important to note that just because it bisects the angle, it doesn't automatically mean it bisects this side. So the angle is cut in half, but maybe this side is not. So we can't follow up with saying that these two pieces are congruent because we don't necessarily know that. We only know that the angle was bisected. All right, so then we've got number 4, and that's going to be coming from the perpendicular. So we know that if two lines are perpendicular to each other, they create right angles. So we need to write that. We need to say that angle XZW and XZY must be right angles. So angle XZW and angle XZY are right angles. And we know that because of the definition of perpendicular. So definition of perpendicular. And now is when we can take that idea of perpendicular and turn it into a congruent statement. Because now that we know we have right angles, we know that all right angles are congruent. So now at this step, I can say angle XZW is congruent to angle XZY by all right angles are congruent. I couldn't have said that before, okay? I need all 3 of these steps in order to go from perpendicularity to congruent. So anytime you start with perpendicular lines and you need to show that the two angles are congruent, you need to use all 3 of these steps. ZX is perpendicular to WY. That means we have right angles by the definition of perpendicular, and that means we have 2 congruent angles because all right angles are congruent. Next step on here, we have a shared side. So XZ is congruent to XZ by the reflexive property. We can mark that. And now we have enough information to prove that these two triangles are congruent. So triangle, got to name them right, WXZ is congruent to triangle YXZ. And the reason for that is angle, side, angle. So angle, side, angle there. And of course, we were not asked to find that the two triangles are congruent. We were asked to prove that WZ equals YZ. So we're going to put a step 8 where we say WZ equals or is congruent to YZ by CP, CTC. Corresponding parts of congruent triangles are congruent. All right, we're not going to do the practice together problem here. You can try it. It is a simple proof, but I want you to get started on your homework. So go ahead and do the 1.6 worksheet. Thanks so much. Bye.